All right, I'm going to do a little bit on this ionic nomenclature, a few examples so that you can see how all this nomenclature plays out. As we talked about in class, there's 4 types of ionic compounds that we'll have to be able to name. 2 of them are binary, 2 of them are polyatomic. Binary means 2 elements, and for those we're looking for 2 capital letters. Those 2 capital letters indicate that there are 2 elements in that compound. For the polyatomics, we're looking for 3 or more capital letters. And again, that's going to indicate 3 or more elements in that particular compound that's polyatomic. Each of those are divided further into 2 categories, type 1 and type 2. That depends on the metal that's involved. If that metal has a predictable oxidation number, one that we can easily look up, then it's type 1. If that metal has more than one oxidation number or more than one ion it can produce, in other words, one that we cannot look up, then that is a type 2. So let's take a look at our first substance here. We have 1, 2, 3 capital letters. That means it's polyatomic. Now we have to decide if it's type 1 or type 2 by looking up the first element, the Na. Na is in group 1A on the periodic table, and all the elements in group 1A will make +1 ions. It's a predictable one. We can look up its charge. This is a type 1 polyatomic. In those cases, we just look at the 2 halves of our compound, the positive part and the negative part, and we just write down the name for each. Na comes straight off the periodic table. That is sodium. OH comes off of our list of polyatomic ions. Its name is hydroxide. For these type 1 polyatomics, we don't change the ending on anything. We just write down exactly what their names are. The metal coming straight from the periodic table, the polyatomic ion coming from the list of polyatomic ions that I gave you to put in your binders. Move on to the next one. 2 capital letters. The 2 capital letters means it's binary, made of 2 elements. To figure out if it's type 1 or type 2, we have to look up Mg. If we take a look at our periodic table, we find that Mg is in group 2A, and all the elements in 2A will make a +2 ion. It's a predictable one. We can look up its charge, so it's type 1. Again, it's got 2 parts, a positive and a negative part, and we're going to write down the name of the positive part, the metal, exactly as it appears on our periodic table. In these type 1 binaries, we are going to have to apply an ending. We're going to have to use the IDE ending on the nonmetal. When nonmetals form ions, their ending changes to IDE. So oxygen becomes oxide. There are not a lot of these nonmetals to worry about. There's only 9 in all. Nitrogen would become nitride. Phosphorus would become phosphide. Oxygen becomes oxide. Sulfur becomes sulfide. Selenium becomes selenide. Fluorine becomes fluoride. Chlorine becomes chloride. Bromine becomes bromide. And iodine becomes iodide. The first 4, nitrogen, oxygen, phosphorus, and sulfur, are a little different in terms of where we chop them off. So you just have to kind of get used to where the root is, where to apply the IDE ending. After a few, you get used to it. In the other cases, you're just dropping the ending, the last 3 letters, and replacing them with IDE. Take a look at the next one, 2 capital letters. Again, that is an L. If it would be an I, there would be a serif on the top and the bottom. It says 2 capital letters, so it's binary. We have to look Cu, the first one up on our periodic table. Let's see if we can find the charge. Cu is copper. It's in the B groups, 1B to be exact. It does not have an oxidation number that we wrote in its box. It does not have an oxidation number in the group above it. So this is not one that we can easily look up. This makes it type 2. Now with the type 2s, we're still going to split it into the positive and negative part. We're still going to write down the name of our positive part, copper. We're still going to change the ending of the second part to IDE. so chlorine becomes chloride, but we're going to leave room in the middle here for a Roman numeral. We have to use the formula to figure out what the charge on the copper is, and we have to include that in the name. Now to do that, we're going to take a look at our total negative charge. We can't do anything with the positive side, but we can figure out what the charge is over here on the negative side. We have 2 chlorines from the subscript times the oxidation number of chlorine. Chlorine's in group 7A. Its oxidation number is -1. 2 times -1 is -2. Now, if the total negative charge in the ionic compound is -2, the total positive charge must be +2 to cancel that out. We just have to take this and do the absolute value to turn it positive, and then divide it by the number of copper atoms, the number of metal atoms, to see what the charge per atom is. There is no subscript on the copper, so we assume it's 1. So it's going to be +2 divided by 1. This is copper 2 chloride. Again, we don't know what the charge per copper is until we figure out the total negative charge. The total negative charge and the total positive charge have to cancel out. We find the total negative charge, make it positive, then divide by the number of metal atoms we have to figure out what the charge per ion is. That's the number that goes in as your Roman numeral. Let's move on to the next one. 2 capital letters. Binary. Lithium, we look it up on our periodic table. It's in 1A, so it is a predictable metal. It has a +1 charge. So this is a type 1 again. Positive and negative side. We name the positive part, and we don't change it in any way. We never will. Because our nonmetal is over here on the negative side, we have to change its ending to IDE. It becomes oxide. Moving on to the next one. This is our first one with 3 or more capital letters in it. This is our first polyatomic, and we have to be kind of careful with the polyatomics. We got to make sure we have our list of polyatomic ions, so we know the names and charges. We got to look for the type 1 and type 2 metals, just like before. It's a little more complicated when it comes time to do a Roman numeral for one of these, so we got to pay extra close attention to these polyatomics. Again, it's the 3 capital letters that make it easy to identify as a polyatomic. We have to look up the metal, just like before, to see if it's predictable or not. If it's predictable, it's a type 1. If it's not, it's a type 2, and will require a Roman numeral. Calcium is in group 2A. 2A is always a +2. So this is a predictable metal. No Roman numeral. We name the positive part and the negative part. This time we're not going to change any of the endings because it's polyatomic. So Ca is calcium. We look up SO4 on our list of polyatomic ions. That is sulfate. Don't change any endings in most polyatomics. The only exception to that would be the next one. For polyatomic again, we have 3 capital letters, but this time our positive is not a metal. The positive part of this is the NH4. It's a polyatomic ion. It's the one positive polyatomic ion that we'll work with. Because it's the positive part, we have to look to see what it's attached to decide how we're going to treat this. If it would have been attached to another polyatomic ion, as the first one here was, we wouldn't be changing any endings, but this is attached to sulfur. And the way we generally treat this ammonium, this NH4, is like a metal from group 1. It's always predictable, it's always a +1. So we would treat it the same way we would do lithium, sodium, potassium, rubidium, cesium, francium, all the group 1 metals. And name this really like it's a type 1 binary ionic. We're going to name it like this one. We're just going to write down what the positive is. Not a metal, this time it's ammonium, the name of which comes from that list of polyatomic ions I gave you. And we're going to change this sulfur to sulfide, using that IDE ending because it is a non-metal that ammonium is attached to. if that ammonium had been attached to another polyatomic ion, we would just be writing down the name of that polyatomic ion. On to the next. 2 capital letters means that it is binary. Now we got to figure out if it's type 1 or type 2 by looking up OS on the periodic table. OS is osmium. It's an 8B or group 8 if you're going by the 1 through 18 IUPAC numbering system. Atomic number 76. It's right in the middle of the table. We don't have any oxidation number in the box that we wrote. We don't have anything above the group. This is a non-predictable group. Metal here is a type 2 binary ionic compound. Again, we got a positive part and a negative part. We're going to go ahead and write down the name of our metal, osmium. And then we're going to take our second part, or nitrogen, and change it to the IDE ending. It's another one of those that gets chopped off shorter like oxygen does. It's nitride. And again, because we're type 2, we're going to need a Roman numeral in the middle. As before, we start with this negative side, because that's the side we can look up. That's the side that's consistent. Nitrogen is always a -3. We're going to multiply it by its subscript. The total charge here is going to be -9. This is obviously not right. I'll take this backwards. That is what happened here. I typed this backwards. I saw that. I knew that was not going to work out. I meant to put the 3 here. And I meant to put the 2 on the nitrogen. And that is just plain typo on my part there. Start over. Again, that's my positive part over here, my negative part over here. Nitrogen's a -3. I'll be multiplying it by 2 for -6. And my positive side has to be +6. I will divide it by the subscript on the osmium, the 3, to get a charge of +2 for every osmium ion. So it'll be osmium 2 nitride. Knew that wasn't going to work because if I ended up with -9 and divided it by 2, I'd end up with 4.5. And nothing has a decimal oxidation number. They're always whole numbers. That's where I knew that one was going wrong. This should be 6, where I divided by 3 to get a whole number 2. Let's move on to the next one. 2 capital letters means it's binary. Look up calcium on the periodic table. It's in group 2A, so it's predictable. So this is a type 1 binary ionic. I'm going to name the positive part, use IDE on the second. That is calcium chloride. 2 capital letters, binary again. I look up the metal, the iron on the periodic table. It's in the B groups. It doesn't have anything in its box. It has no number above it. This is not predictable. It's a type 2. So again, positive and negative. We have iron. We know we're going to have a Roman numeral in there. Oxygen changes to oxide. Now we're going to figure out that Roman numeral. And again, we're going to focus on this part to do that. Oxygen is always a -2. That comes from the periodic table. That is its oxidation number. It belongs to group 6A, and the nonmetals in 6A form -2 ions. We're going to multiply it by that subscript for a total charge of -6. The positive side has to be +6 divided by the 2 iron atoms that we have. Each iron atom has a charge of 3. This is iron 3 oxide. 4 capital letters this time. We have 3 elements in all. So it is polyatomic. Again, our positive is that polyatomic ion ammonium. This time the negative is a polyatomic ion. So there's no endings to change this time. It would be ammonium. We're never going to change the name of a positive ion. And OH comes from our list of polyatomic ions. It's hydroxide. Never ever change the name of a polyatomic ion. When you're writing their formulas, you have to preserve their subscripts with parentheses. When you're writing their names, you never change their names. What it says on that table of polyatomic ions is what it is every time. 2 capital letters means it's binary. We look up Be on our periodic table. It's in group 2A, it's the first element in group 2A. Everything in 2A makes a +2 ion, so it's predictable. No Roman numeral. Name the positive part. This is beryllium. And then chlorine gets the IDE ending. Become chloride. 3 capital letters means it's polyatomic. Positive is nickel, the negative is SO4. We look up nickel on the periodic table. It's in the B groups. There's nothing in its box. There's nothing above its column, so it's not predictable. We're going to have a Roman numeral. Ni is nickel. SO4 comes off of our list of polyatomic ions. That is sulfate. Again, be careful with some of these. There's an SO3 on there too. That would be sulfite. Check the subscript, check the names to make sure that you are getting them correct. SO4 is sulfate. We are going to need a Roman numeral in between. Now we look up SO4 on our periodic table, on our list of polyatomic ions. It's a -2. The question is what to multiply it by this time. And the common mistake would be to multiply it by 4. But we have to remember that that's just part of sulfate's symbol. If there would be 4 of them, it would be in parentheses and there'd be a 4 on the outside. Because there are no parentheses around the sulfate, we know there's only 1 for a total negative charge of -2. Again, if you have parentheses, you go by what's on the outside. If you have no parentheses, you multiply by 1. The total positive charge has to be +1. We're going to divide that by nickel's subscript 2. That is nickel 1 sulfate. Again, 3 capital letters, polyatomic. Chromium, again, not predictable. Write down the positive. Write down the name of this polyatomic ion. NO3 is nitrate. There is a nitrite, so be careful. Check those subscripts and make sure you're using the right one. For the Roman numeral, we work with the nitrate, the NO3. On your table of polyatomic ions, you can see it has a -1 charge. When we have parentheses, we multiply by what's on the outside. No parentheses, multiply by 1. When you have parentheses, multiply by what's on the outside. Total negative charge is -2. Make that positive and divide by the number of chromium atoms. So our Roman numeral here is 2. And another one, just for good measure, molybdenum is not a predictable metal. It's in the B groups. That's our positive part, that's our negative part. Check the spelling there. Molybdenum, SO4 is sulfate. Again, we're going to need a Roman numeral. We look sulfate up on our table of polyatomic ions. It's a -2. We multiply it by what's on the outside for a total charge of -4. We'll make that positive, and we will divide it by the subscript, or lack of subscript on molybdenum here, 1. For 4 as our Roman numeral.